This episode brings to life the ops team's challenge of missing notifications when critical documents arrive and how it was fixed. Let's get straight into it. First up, we've got our S3 bucket already created and ready to go. If you want a step-by-step guide on setting one up, check out the previous video. Inside our bucket, we've created a folder called Incoming. We named it that way to clearly represent its purpose. This is the entry point where all new documents land. After that, head over to the search bar and type in SQS. We're going to SQS because we need a reliable way to capture and queue events whenever a new document lands in our S3 bucket. It basically acts as a buffer, making sure no notifications are missed, even if downstream systems are temporarily busy or unavailable. Create a queue, choose a standard queue, and give it a name that matches your project so it's easy to recognize later. Then set the access policy to Advanced, JSON. Add two statements. One gives the queue owner full access, and the other allows S3 to send messages. SQS:"send message." We do this because S3 needs explicit permission to push events into the queue, and scoping it to your bucket ARN ensures only your bucket can trigger it. Once you're done, scroll down and click Create Queue. Now that's done, head back to your S3 bucket and open the Properties tab to create an event notification. We're doing this to configure S3 to automatically react when something new is uploaded. Instead of manually checking the bucket, S3 will publish an event to our queue whenever a file is uploaded, enabling an event-driven architecture and ensuring downstream services are notified in real time. Now make sure to fill in the event name, prefix filter, and suffix filter. Event name helps you easily identify what this notification is for. Prefix filter limits events to a specific folder, for example, incoming/. Suffix filter limits events to specific file types. We do this to control exactly what triggers the notification, so only relevant files send messages to the queue, keeping things clean and efficient. And set the event type to put. We do this because a put event is triggered whenever a new object is uploaded or an existing one is updated in the bucket. This ensures our queue only receives notifications when new files arrive, which is exactly what we want to track. Scroll all the way down and set the destination to SQS queue. Under Specify SQS queues, select Choose from your queue options and pick the queue you created earlier. We do this to connect S3 to SQS, so whenever the event is triggered, the message is automatically sent to your queue for processing. After that's done, go to the search bar and look for SES. SES is what we use to send emails. So once a file is uploaded and the message flows through our system, SES lets us notify users by email. Now click on Identities. As you can see, my email is already verified. If you're not sure how to do this, check out our blog for a step-by-step guide. Now it's time to set up our Lambda function. We're doing this because Lambda is what processes the message from the queue. It acts as the brain of the system, taking the event, handling any logic, like extracting details or formatting, and then triggering the email via SES. Without it, the message would just sit in the queue with nothing acting on it. Make sure to give your function a clear name, and for this setup, choose Python as the runtime. It will show a success page. From there, go to the Configuration tab, then Permissions, and click on the role name. These roles define what your Lambda function is allowed to do. We need to add the right permissions so it can read messages from SQS and send emails using SES. Without these roles, Lambda won't be able to interact with other AWS services, even if everything else is set up correctly. Now it's time to paste in the code. The code will be available on my GitHub account, so you can copy it from there and drop it straight into your Lambda function. Click on Deploy to deploy the function so your latest code is live and ready to run. Now click on Add Trigger. We're doing this to connect the Lambda function to our event source. This tells Lambda when to run, so whenever a message arrives in the queue, the function is automatically triggered to process it. In the trigger configuration, select SQS, then choose your queue from the drop-down options. Set your batch size. This controls how many messages Lambda processes at once, and then click Activate Trigger. You should now see a confirmation message showing that the trigger has been successfully activated. From this point on, whenever a document is uploaded into your incoming slash folder, the entire pipeline kicks in automatically. S3 sends the event, SQS queues it, Lambda processes it, and SES delivers an email straight to your inbox with a formatted HTML summary. Go ahead and test it by uploading a file, then check your inbox for the notification. And just like that, you've built a fully event-driven notification system. No manual checks, no missed updates, just real-time alerts flowing end to end.